In this video clip, we are going to be testing a claim about a mean when the standard deviation is unknown of the population. And we will be using a sample standard deviation, and this is dealing with hypothesis testing. We're going to take a problem that is in section 8.5 that has a set of data that we're going to use to look at our claim. But what happens in this problem, it says a safety administration conducted crash tests for child booster seats for cars. Listed below are results from those tests with the measurements given in HIC, Standard Head Injury Condition Units. The safety requirement is that the HIC measurement should be less than 1,000. Use a .01 significance level to test the claim that the sample is from a population with a mean less than 1,000. Do the results suggest that all the child booster seats meet the specified requirements? Now, notice that we have the claim that the sample is from a population with a mean less than 1,000. So if we translate this into symbols, we have the mean is less than 1,000. We have a section down here where we're trying to determine which one we're working with. Here's where a mean is less than 1,000. Here's where a mean is less than 1,000. The other two we do not have. There's a means less than 1,000. But we have to remember that the null will always have an equal. So in this, the alternative does not. So this would be C, where we're translating the claim to symbols and then writing our hypothesis statements. Next, they're going to ask us to identify the test statistic. Now, we're going to do this with a calculator. Since they gave us a set of points, and by the way, when you look at this, notice at the top, assume that a random sample has been selected from a normal distribution. So we're able to work this problem because they've defined this with a normal distribution. The sample size is not greater than 30, so we have to check that. So since this is a normal distribution, we can continue working. Also, notice it gives us a sample standard deviation in this problem, or they'll give us a sample, so we will actually have to think about, we could take these numbers from the other sections that we had and calculate the mean of the sample and the standard deviation of the sample. Well, the way we did this, we went to stat. Let's see, let me clear this out. Push stat, push enter, and type in the values. Now, if we wanted to go in and find our mean and standard deviation, remember we learned to do the descriptive statistics. We push stat, move over to calculate, and pick number 1 because it's one variable. And if you push enter, we can see that the mean is 757. The standard deviation of the sample is 248.87. And so this is the values that a lot of times they'll give you in the problem as your statistics. But we were able to put them in the list and find those. But what we want is to identify the test statistic. And since we are dealing with a standard deviation of a sample, we're going to use T. So we're going to stat, we're going over to test, and we're going to pick number 2, the t-test. Now, we have a set of values, so we're going to select data. So I'm going to highlight that. Notice if you look at your claim, the mean equals 1,000, so that's what we're typing in for the mean. My data points are in list 1, so I'm going to put that 1. Frequency is 1. And notice my alternative says less, the mean is less than. So I'm going to put a less than symbol. I'm going to come down. And I'm going to draw this for a second so we can see what happens. Now this will be important in a few minutes, the drawing, because we will have to pick out a critical value. And we need to think about, this is a left tail test. And so when we use our table in a few minutes, we're going to do area and one tail instead of 2 tails. So I just want to draw this to show you this is what this looks like right now, currently. We can see that our test statistic right now is is negative 2.39, negative 2.392. So we are going to have to type that in, 392 negative. So let's type it in as our solution and see what happens. And notice that's correct. Next thing, it asks us to for our p-value, and we can see that the p-value is listed on our graph. We have 0.0311. That's the area under the curve. Notice this shading is to the left because if you look at our alternative statement, notice it said less than, so that's what I have. Now this is the part that we need to use our formula sheet to find the critical value. Notice it is a 0.01 level of significance, and we have 4, 5, 6. We have 6 as our sample size. So let's call up our formula sheet. Now remember, degrees of freedom is n minus 1. Okay, so we're going to be looking at 5. And remember, our graph is to the left, so it's area and one tail, which is up here at the top of the table, and it's 0.01 it said. So we are looking at the number for the critical value, and this is in table A3. Notice our critical value is 3.365. Now, you have to remember, the area was to the left, so we will have to put in the negative value. So negative 3.365. There are two critical values, a positive or negative. You determine which one you'll use based on the tail. If it's a left tail, it's negative. If it's a right tail, it's positive. If it's a not equal, you actually put both of those in with a comma. And we check our answer, and it's correct. Now, we have to make a conclusion about this. And what happens is it says state the final conclusion that addresses the original claim. Now let's go back and use the p-value method and see what happens. Notice the p-value is 0.03 and our level of significance is 0.01. Well, this is larger. So what happens if this is larger, then in our hypothesis statement we click this. We're going to fail to reject the null. Okay. And then if we pull up our table and we scroll down, let's see, let me find it. Here. Okay, so our original claim did not have an equal sign. Okay. And do you reject the null? No, we failed to reject. So there is not sufficient sample evidence to support the claim. So we come back. There is not sufficient. There is sufficient. There is insufficient. We'll use that. Whoops, come back. Insufficient. And so we will check our answer, and we have it correct. Now, remember our problem, what we were talking about. There is insufficient evidence to support the claim that the sample is from a population with a mean less than 1,000. There's not enough evidence to support this claim. Okay, so if that's so, it says, do the results suggest that all child booster seats meet the specified requirements? And if you look up at the top, a Safety Administration conducted crash tests, and these are listed below. Notice the safety requirement is that the measurement should be less than 1,000. Okay, and we are claiming that the sample's from a population with a mean less than 1,000. Okay, so we just found out that there's not enough evidence to support that most of these are in less than 1,000. So there's not strong evidence that the mean is less than 1,000 and one of the booster seats has a measurement that's greater, or the results are inconclusive. There's strong evidence that the mean is less than 1,000, or yes, because the majority of the sample measurements are less than 1,000. So do the results suggest that all child booster seats meet the requirement? No, there's not sufficient evidence, so we check that. So this is an example of where you will use a t-test, and also I want you to pay attention to when you do critical values. When you look at your table, do you use a one tail? Do you use a two tail? The only time that you're going to use on the table, the only time that you'll use a two tail test is when you have a not equals in your alternative. That's when you'll use this row. And if you have a greater than, you'll use this row with a positive critical value. If you have a less than, you'll use this row with a negative. So this is an example of a problem that we did in section 8.5.